The talk is turbocharging the UIs at Zomato. So Rohan Gupta will be joining us, who will be giving a talk on the topic. He's a software engineer at Zomato, and he's also a Microsoft Learn ambassador, and he has an expertise in OTT and video streaming technologies.
Hello everyone, welcome to React India. I am Rohan Gupta, currently working as an SD at Zomato. Hope you all are pumped up for today's session. So let's get started. A little about me. I work in the domains of web development, primarily focusing on building bulletproof and scalable products. I love to sail in the boat of web security and reverse engineering. And my passion extends to OTT platforms, video streaming, web players, and many more such things. Apart from that, I am a maintainer of LimePlay, a UI library designed for video players. Okay, so the moment you try to build at scale, everything gets a little more spicy. So at Zomato, we have been navigating that spice level, and recently we adopted two strategies to help us out. And that's what I'm here to share with you all today. Let's dive into what we have learned and how you can scale your apps definitely without losing your mind. Okay. So to build a standard web application, you really just need two main things, the UI, what people actually see, and the data, what people actually care about. And everything else, it revolves around these two pillars. So you can consider third pillar as well, that is runtime, where you would be doing your UI plus data equation, but that's obvious. So ruling that out. Okay, so just having a nice UI and decent data isn't enough, right? And we are all about delivering that the best user experience. That means reducing the load times, building super performant applications, and apps that run at smooth 60 FPS. Right. So if you are anything like us, you might have a little obsession with that perfect lighthouse score, that 100 out of 101, right? It's like the developer's equivalent of a six pack that we all want, but it takes a lot of work to get there. So, and for that, you need to focus on every single lighthouse metric without any shortcuts. For now, let's talk about React Server components. So my manager at Zomato sees it as a potential paradigm shift, and definitely he is not wrong for there. And for years now, we have been working with a limited set of rendering strategies in React, like it may be CSR, SSR, SSG, ISR, and whatnot. So if you have been in the game for a while, you would probably know these on the first name basis by now. But here's the thing, no matter how fancy verb you are using, there is always one common piece, that is data. And when it comes to data, especially in the world of restaurants, we are usually talking about server side. Before I dive headfirst into React Server components, let's take a quick bit stop and glimpse of each of these rendering strategies to discuss them. So the first one is CSR, that is client-side rendering, a standard rendering strategy, which came with a Create React app, allowing you to bundle everything and upload it to a static server, which serves the assets and no additional overhead cost. Of course, we are excluding the storage and serving assets because that's obvious and common among the all. A heavy application which relies completely on the client-side JavaScript comes with no or minimal initial HTML, right? Until you define it. So at Zomato, we commonly use this strategy for our internal administration dashboards and toolings. The second one's is SSG, that is static site generation. It is a successor to CSR, which relies on both client and server to generate builds once during a release lifecycle and then uploading all the assets to a static storage. This is a subtype of SSR where parts of the page which are known or significantly or known to remain static are fetched once during the build time and their respective HTML is output. So this is more feasible as it significantly reduces the client-side JavaScript and waterfalls, thus increasing the TTI metric, that is time to interactivity, and not requiring the client to fetch initial data again from the server, like in CSR, what we saw earlier. This is much popular at Zomato and heavily used and even encouraged strategy for React applications today. Here, commonly used to generate web views, which we show in our app. And recently, our Weather Union app was built on the same strategy to render more than 700 static pages. Third one is ISR, that is incremental static regeneration, a subtype of SSR strategy where pages do render at the server but have a life cycle, or say they are asynchronously updated when the data changes. For low velocity data that changes less frequently and shall remain same for everyone, we can possibly cache that page without requiring the server to render it every time on demand, thus saving the server cost. This does require you to have a constant running server, but at a low scale, as caching would be present, it will help you decrease the throughput. So it comes the best at its part and increasing the efficiency. Our blog, that is blog.zomato.com, leverages this strategy. The fourth one strategy is SSR, server-side rendering, which is true server-side generation, where data fetching and rendering happens all on the server for most of its part, and hydration then occurs on the client, providing the users with the best real-time experience, but at a high runtime cost. We have been using SSR on Zomato Live, that is zomato.com/live. You can check that website, and you would see a highly performant site optimized for most of the devices and network. So, as React team mentions in their official RSC announcement blog post, that RSC has been provided as a specification, and respective frameworks are supposed to follow and implement it on their own end. So Next.js was the first to bring the native support of RSCs, and I highly recommend you to go through the above blog from React team for their official RSC announcements to get more insights. Though we were not a big fan of Next.js until Next 13 came, we found it much of an ecosystem with limitations and less scalable for our custom needs, and of course the issues related to data fetching, which we will be discussing moving ahead. With the support of RSCs, we found it a game changer, as it brought most of what we needed to move to this framework with its new app router. Since we already had hands-on with it in past, we found it a cakewalk to jump straight onto it. So we have already covered how we will deliver our UI. And once you have logged in our rendering strategy, it's time to talk about the next big thing, that is data. Because without data, we have just got a pretty shell to stare at, right? Now, if you want the best user experience, fetching as much as data possible on the server is the trick. Why? Because data source is closest to the server, which means faster response time, and everyone loves a fast app, right? As React enters Next 13, where things got really interesting, alongside the React team, they introduced this app router, which was a huge step forward from the old pages router. And here's the thing, the new app router doesn't, it comes with a built-in support for React server components, and it doesn't just stop at it. It's packed with several new features and improvements, specifically when it comes to data fetching on the server side. So we will now see the difference between old pages router and the new app router fetching technique to understand how React server components solve the real world problem that have been plaguing the Zomato's front end ecosystem for far too long. In Next.js pages router, data fetching was single entry point, which means for all the data that you need on the page, you can ask via the get server side props function, which can only be defined at the top level of your project. That is index file of that respective page or folder wherever you are initializing the page. This essentially also means that you can either fetch on the client or on the server. And for the server, you can only ask once, that is before when the page is rendered, which logically sounds fine and definitely doesn't have any issues. But with this approach working fine for many, at scale, there were some bottlenecks, which we realized as the framework grew and introduced the need for RSCs. Let's discuss those. First is choking single entry point. Say you have an application which has header, sidebar, and the main content having some blog posts, and data of each of the section is independent. So to achieve the best, you would ideally fetch the data for all the three sections in parallel on the server. Consider the case where header and sidebar are resolved first, let's say 200 milliseconds and 400 milliseconds respectively. And the main content data call resolves in 800 millisecond, which is actually 400 more millisecond to complete. Now, with this architecture, the user would be seeing skeletons for that extra time by which we could have shown them the header and the sidebar. But guess what? We awaited them until everything was resolved on our end. We see the problem here, right? Here, we awaited the user due to our technical limitations while we fetched the main content data. Now, some of you would say it's still possible. One would suggest to fetch on client, but no, we aren't using the full of the SSR and compromising a lot, right? Um, we need something that is more similar but performant. And also, additional round trip calls for the same data, which server could have easily got. We can't afford this in this case, right? And some would also feel it is fine. Yes, it is at some scale. But as 10x developers, we must never leave room for that unused optimization, right? We need something which is best of the both worlds, that is CSR and SSR, to solve the problem. That's when we got to know what was the data fetching problem in React frameworks. And uh, let's now move ahead and discuss the next problem, that is poor developer experience. Since you could only fetch the data from one function, that is get server side props, which could get as complex as it could be. This also means that the data, managing that data or consuming that data would be that much difficult as well. So developers often found it frustrating as prop drilling was the only possible solution on the server with the pages router, and managing such a large data, nested data, could become really complex at that scale. So with both above problems being considered, doing everything on the server became a limitation for complex use cases, specifically because of the React framework that we are not using, and not just because of the server can't do. This had to be fixed, and let's see how things worked in App Router ahead, which would give us a clear picture how RSCs fit under the hood. Let's start with an example. This is a minimal example of rendering a UI with data. As you would noticed, you can fetch anywhere, and that's the paradigm shift. No defined functions like get server side props, and you now have the full control to fetch the data in any way you want, be it a page or a component. And fetching data is not just limited to fetching by the fetch API. You can even make a database call inside a component as shown in the example above. This clearly solves what we discussed in the second problem about the poor developer experience in the pages router being solved here. Developers now have the freedom to write more generic code with the flow of the UI. But what about that choking single entry point problem we discussed earlier? You will get to know more about this as we move ahead. So these modular components aim to do fully on the server as the name suggests. A key point to note here is that server components cannot use any client-side feature like React states, references, interaction, or browser APIs. They run solely on the server and render once on the client, bringing the zero bundle size feature, which means that server component doesn't come with any additional JavaScript, and it solely has the final UI in the form of a descriptor, which is called RSC payload, which the client consumes. For more on the architecture and design, you can refer the RFC introduced by the React team linked in the slide to understand how they internally work. For the problem we discussed earlier, RSCs fit really well here as a solution. They defined client and the server boundaries by a directive on the top of a file like use client, which marks a component as a client component, and by default it is marked as a server component if you don't specify it. So if you are trying to access a client-side feature like React State without specifying use client directive at the top, it will give you an error. So to solve this delayed data fetching problem, just like the blog example which we discussed earlier, React adopted HTTP streaming. Streaming enables you to progressively render the UI from the server. Here the work is split into chunks and streamed to the client as it becomes readily available. This allows the user to see parts of the pages immediately even before the entire page has finished its rendering. In a single HTTP request, the connection is kept alive, and as the response is generated, it is sent to the client, and browser lazily keeps on rendering it. This is the best of both worlds. CSR and SSR, what we actually needed. Here, you would provide a fallback value to the client. So it will show that value by the time server has generated the value for that asynchronous operation which was being performed on the server. You would now start to realize how efficiently the problem was solved here. In general, the frameworks router manages this logic of joining the blocks of the client and server components. You can visualize RSC as an isolated component which would actually just smoothly fit like a piece in a puzzle. So there is a rule set of RSC, which you can again refer from the same RFC from the React teams. You can check that as well for the better understanding and the usage of these RSC concept. So to summarize the points mentioned here, first is code splitting. RSC can help you do that automatic code splitting where it will know the boundaries based on the natural code flow, and it will automatically treat all imports of client components as potential code split points. The net effective is that server components let developers focus more on their app and write natural code. We have full access to runtime or say backend without any limitations. Your server components can access database, APIs, files, or anything in real time without exposing them to the client. Any of this code will automatically be removed from the final output, which is sent to the client as a response. Third one is zero bundle size. Heavy lifting on the server is now much more easier as server components don't ship any additional JavaScript with them. Using markdown parsing libraries on the server is now more efficient as they would never be fetched on the client, but the output of those. So the operations of that library will be performed on the server, and the output from that library or say function, which whatever you are using, will just be sent to the client, and client will no longer be need to make use of these libraries. For this, no client server waterfalls. With the support of RSC combined with suspense and streaming, no additional round trip calls are now required, which hence reduces the latency and improves the performance on the client device. Within any client component, data can be fetched and lazily sent to the client in the same request response lifecycle, hence reducing the client server waterfalls. At Zomato, our Weather Union platform is a fully static SSD site. It was the first to embrace this new approach, and the end results were honestly mind blowing. We were able to load a massive amount of client side data without sacrificing the performance, even on mobile devices. Now, that's a big deal because mobile is where many performance bottlenecks actually show up. This website has a video, carousels, data heavy interactive maps, and everything on the landing page, which is a UI engineer's nightmare. By cutting down on the amount of client-side JavaScript and leaning more into server-rendered static content, we were able to hit some of the best lighthouse scores we would have ever seen. Post-launch, we continued to see incredible performance gains. Users are getting faster load times and smoother interactions. Once we got comfortable with React Server components on our first project, that is Weather Union, we knew we were onto something. So that with that confidence, we decided to take things up a notch. Zomato Live, our next big project built on Next.js 14. This time we went all in with RSCs, and guess what? We were able to serve a lightning fast experience without breaking a sweat. The best part is that even with this massive data and real-time updates in Zomato Live, we still managed to deliver a performant experience across the devices. So after Zomato Live, React Server Components officially earned a VIP spot in our toolkit. It has been amazing to see how much we can push on the performance. As you know, as we are engineers, we are always on the lookout for the next big cool thing or the framework or the library, whatever comes in the market. So that's all about RSCs. In case you find it mind-boggling initially, don't worry, that's expected. Just skim through the docs and you should be fine for the most of the part. With this being done, it brings me to the next challenge that we tackled, that is remote UIs. If you would have ever thought like managing one UI is fun, but wouldn't it be even more fun to manage multiple UIs across different applications within a single entry point? So the story of how we got into model federation actually starts pretty randomly. As someone from our team just happened to play around with its capabilities on a weekend while browsing the Webpack docs last year. So, as Zomans, what we are called in Zomato, if there is a problem we can solve and improve user experience, we jump straight onto it. And at that time, we were already cooking up plans to solve the problem of large monolithic front-end applications of Zomato. We were brainstorming what ways to break them down into smaller manageable pieces when Module Federation came along like a superhero. It was exactly what we were looking for, way more promising, and we dove headfirst and started building. To give you a bit of a context on the problem we were facing, let's focus on the restaurant partner side of Zomato. They primarily use a web app to manage pretty much everything about their outlets on the platform. Daily business operations like ordering, analytics, managing ads, promotions, and a whole lot more. And all of that is a single, very large and complex entry point, what we call the restaurant partners dashboard. It's like a giant admin control center powering everything behind the scenes. Now, here's the fun part. What users see on the front end, that is the Zomato app, is just the tip of the iceberg, where everything looks nice and smooth. But beneath the surface is the bottom of that iceberg where all the heavy lifting happens actually. Think of it again like a giant admin control center powering everything behind the scenes. And just like icebergs, it's massive, intricate, and way more complicated than what anyone ever sees in the first glance. So this application was a monolith web app initially, where several teams are working on their respective sections and eventually converging. This started increasing the friction as the operations grew, more features came in, and features were added. Different teams became interdependent, like collaborating in other segments of code, planning releases, monitoring deployments, and build times and many more. We knew that it's time to move towards micro frontend, but migrating a massive monolith, which is at this scale, to a micro front-end architecture, that too with direct impact on our revenues, not an easy job, right? It wasn't just impractical, but wildly unfeasible at this stage of the game. So we needed a modern scalable solution to handle this very shady problem without flipping the entire system upside down. And as I mentioned earlier, it's when we turned to module federation. So, what exactly is module federation? In simpler terms, it's a bundling concept introduced by Webpack that allows you to split an application into isolated segments or micro frontends. Basically, you are taking your existing app and breaking it down into smaller independent managed pieces that can live harmoniously in a single application. This unlocks some seriously cool capabilities, especially when it comes to providing a unified user experience. Behind the scenes, each of these module or micro app uh, is its own UI application, completely independent but stitched together seamlessly on the front end part. And for those of you who are wondering how this actually works, think of it like a website loading an iframe, except that it's way more polished and without that clunky iframe look. The end result is that user never even realizes that they are even interacting with different or independent applications. Here you can see different modules or micro apps getting loaded on demand. Our partners app was natively built in React, and here the ad center you can see in the image is built on a completely different stack. Whole flow is seamlessly stitched together with data being exchanged among these micro apps without any separate bridge. As we are building and scaling, we are migrating to module federation because of the ultimate benefits that it brings along with it. Now, straight from the official docs, module federation is an architectural pattern for decentralization of JavaScript applications, similar to microservices on the server side. It basically allows you to share code and resources among multiple JavaScript applications or micro frontend. The fun part is at Zomato for restaurant partners web app, this became an absolute game changer. After months of engineering and testing, we were able to successfully implement module federation, and results were like flipping a switch. Suddenly, teams could work independently without even getting tangled up in those conversations about release schedules, tech stack updates, management, or dependency closure. Developers experience went through the roof and shipping speed just got a major boost too. That's what's the power of module federation. Case with the ads tech team, they were able to build and launch their first ads management center for restaurants partner without even needing to mess with the older web apps tech stack. It was like they had their own sandbox to play in when it was done, it seamlessly plugged into the existing merchant app. Now, restaurant chains have even more power to manage their ads across the application. It all just works seamlessly, and no one even had to coordinate on the every little thing. This independent ad center would be opened, can be easily opened inside any web, Android, or iOS application without having to worry about any dependency or access control. So that's it on the module federation, our second strategy, which we adopted. I have attached some references which you can refer if you want to glide through the concepts. Feel free to check them out. So we just discussed two of our recently adopted strategies. Regardless, we didn't find our perfect framework, but as the saying goes, it all depends on the use case. As we speak, we have apps running on Next, Astro, Svelte, Remix, and Vanilla, React, and whatnot. The more we work with open source, the more we support it and the more we love it, definitely. We continue to explore and play around with the new tech and share our learnings with the community. And yes, that's it for today. Hope this session brought you feelings of hunger, salivation, cravings, and drools. Okay, that's it from my side. Thanks.